I am Marco Chucky. I was a ball thrower and the measurements.
I'm Alejandro Pufelis, and I was the experiment setup manager.
And Ivan Leonard was a videographer.
And Lucas Thomas was a data recorder.
Our time slot was February 28th from 2 to 3 p.m.
To calculate the coefficient of restitution E, we performed an experiment. We dropped the ball from a height of 40 centimeters, and we calculated the bounces after. The coefficient of restitution is calculated using the equation E equals H1 over H naught, or H2 over H1, and finding all the averages. That ended up giving us a value of E of 0.36.
We use the plastic ball in the long range as a speed setting in order to calculate the velocities, initial and final velocities, as well as the angles. We recorded the ball drop, and we used the tracker to calculate the initial velocity, the final velocity with the angle theta, the incident angle, and the angle alpha of the resultant velocity. And these are the values that we obtained. To calculate the final velocities, we use what's the coefficient of restitution formula. Here we know that VB2 and VB1 is 0 because the plate is fixed, and we're given VA1, which makes it very easy to calculate VA2 given the angles of incidence.
Using the equation for the coefficient of restitution, we obtained these values for VF, which are all in feet per second. As you can see, they are similar to the experimental values.
We recorded the ball drop and used a tracker to track the motion of the initial velocity and the angles, which tracked the initial velocity, the final velocity, the relative angles, as well as the movement of the plate as the ball hit the plate. And these are the values we obtained by using the tracker.
Besides only calculating VF experimentally, we also use theory to find it. We use the energy work theorem to find it. Here we start with initial kinetic energy, and these are the forces that do work, being gravity and the spring force. We add these up and we solve for VF to get those values. Using theory, we got very similar answers for most of the values for VF.
Using theory and with the values approximately of x equals 0.01 and h equals 0.024, we calculate the final velocities to be in some way similar to the ones calculated experimentally. Some of our results using experiment and theory were varied a little bit due to the main reason was source of error. There was a source of error in the tracker which could have not gathered the points as properly and given us some faulty results. Also, when we recorded the ball drop, the camera is not as fast for the frames per second, so that could have altered our results, as well as the errors in measuring when we measured in rulers and the tracker, which wouldn't give us a precise number. Also, the theory we used considers a perfect environment, meaning that it doesn't consider any friction, any energy dissipation, any air drag, etc. So those could have been the factors that altered our final velocities and the angles we got.